everyone, welcome to the session. So in this particular video, we will talk about the sorting algorithms. So let's discuss about that. So these algorithms, whatsoever we are discussing here, that also we will apply on top of an array-based data structure that we have already covered up. Let's get started. So first of all, whenever someone is telling you that sorting algorithm, so what does that mean? What is the meaning of a sorting algorithm? Sorting algorithm. The simple meaning is that given a set of elements which are stored in any data structure, for example, as of now we are talking about an array. So suppose I am having some set of elements. For example, here I am having 20, 10, 12, 17, 27, 42, 39. Suppose these are the elements that we have, which are stored in an array. Now here we are having the index numbers also, right? It will start from 0, then we'll move ahead 1, 2, 3, 4, 5 and 6. So here in total I am having 7 number of elements, correct? When I am applying any sorting algorithm, so whenever we are applying any sort of a sorting algorithm, so what we are trying to do here is that, just try to understand here. Suppose you have applied any sorting algorithm. So let me tell you, there are so many sorting algorithms that we have, but there will be a broader classification of that we will discuss here. So when you apply any kind of sorting algorithm, the expectation will be that you will give an array either in ascending order or in descending order. Means either in increasing fashion or in decreasing fashion. For example, the expectation will be that your array should look like 10, then 12, then 17, then followed by 20, then 27, then 39, and then 42. So this is a kind of an array which is expected from you or from your code. So this is the indexes that we got as a final output for each and every element that we have. This is the meaning of sorting. So this is something which we called as a sorted array. This is something which we called as a sorted array. So here basically what we are trying to do is that we are expecting that given any kind of array that we have, once I will apply any kind of a sorting algorithm out of so many sorting algorithms that we will discuss in our course, the expectation will be that the array should look like this manner. Now, how many different kinds of sorting algorithms we have? As I told you that we are having a variety of sorting algorithms, and we will understand that at what point of time or at what scenario which particular sorting algorithm we should go for. But before understanding that point, let me try to give you a very simple example. If suppose someone is asking to you that how many different kinds of sorting algorithm do you know? Students generally say, or they generally start with, I know bubble sort, insertion sort, selection sort, merge sort, quick sort, count sort, radix sort, bucket. No, this is not the correct way to answer this question. Your answer should be that broadly classified, the sorting algorithms is divided into two parts. So any of the sorting algorithm, whichever you came across, is broadly classified into two parts. One is something which we called as a comparison based sorting algorithm. Comparison based. Okay. Another one is something which we called as non-comparison based sorting algorithm. Non-comparison based sorting algorithm. Now what does that mean? When I'm saying that comparison based sorting algorithm, the simple meaning is that here the array elements that you have, they are doing some sort of comparison. So comparison goes on within the values that we have inside the array. As the name suggests itself, comparison based. So when we talked about comparison based sorting algorithms, we will see that inside those algorithms, there is always a comparison within the values that we have. But when we talk about non-comparison based sorting algorithm, you will observe that Internally, values are not comparing. It's just the internal structure, the characters or the words that we have or the numbers that we have. We are doing some other thing apart from the direct comparison within the values. So in a broader sense, we are having two different kinds of sorting algorithms. One is called as comparison based, another one is called as non-comparison based. When we talk about comparison based, so here comes that there is a comparison within the values in an array that we have. For example, we have maximum sorting algorithms under this category. So the very basic is selection, sort, the bubble sort that we have. Every sorting algorithm, whatever I am writing here, we will discuss in our course. Selection, bubble, afterwards you should know about insertion sort. After that, you should know about quick sort. Okay. After that, there is a merge sort. Afterwards, you have heap sort. So these sorting algorithms are the algorithms which came under the category of a comparison based. It means that whenever I am using these algorithms, you will observe that somehow I am comparing the values, the numbers that we have inside the array with each other. And then I am doing a sorting algorithm. Obviously, the final output will be same for every sorting algorithm that you will apply. Now the question which should come in your head is that if we can do this thing with one algorithm, for example, using selection sort only, we will be able to get a sorted array, then why there is a need of so many sorting algorithms? You will easily able to get that once you will be able to get an idea of all these sorting algorithms. Because what you need to understand in step by step when I will talk about these sorting algorithms, first of all, you need to understand the approach of every sorting algorithm. Okay. You just need to focus on the approach on the very first thing. Secondly, you need to understand that on what scenarios mainly, which sorting algorithm will be the optimized one. How you will get the optimized one? How will you compare that whether this sorting algorithm is optimized or not? By using the concept of, everyone I hope now knows, time complexity and the space complexity. By using the concept of time complexity and the space complexity that we have. So here, these two things we should know pretty well. For each and every sorting algorithm, whenever I will write the code, I will try to discuss about these specifically time and space complexity. And then we will also discuss that at what point of time, means that at what scenario we should go for what kind of algorithm, right? Apart from that, then you have a non-comparison based sorting algorithms as well, where there is no as such comparison of the numbers or the values that we have inside the array. In this, it includes maybe the count sort that you have. This includes the radix sort that we have. This includes the bucket sort that we have. So here basically we are having mainly these three different kinds of sorting algorithms which came under this category of non-comparison based sorting algorithm. Here if you will talk about this quick sort and this merge sort, these two came under the applications of divide and conquer. These two came under the applications of divide and conquer module. So when I will talk about this module, at that point of time only, we will try to discuss these two quick and merge sort. But apart from that, everything we will try to discuss in our array based data structure only, because I want to show you that with the help of that data structure, what things we can do. Then only I think you will be able to appreciate that data structure pretty well, right? So that is the overall idea behind the sorting algorithms that I want to give you with the help of this video. So in this video, in a nutshell, we have understood that in a broader sense, we have two different types of sorting algorithms. One is called as comparison based, other one is known as non-comparison based. We have seen what is the major difference between these two things, right? And then we have seen which sorting algorithms comes under the category of this comparison based and what sorting algorithms will come under the category of non-comparison based. Afterwards, I have also talked about that what things you have to keep in your mind while moving towards the next videos, where we will talk about the different kinds of sorting algorithms that we have. One thing you need to see that how one sorting algorithm is different from another one via approach, logically how it is different. Secondly, you have to see that in what scenario it will be beneficial for us to use that kind of sorting algorithm or the another one. On the basis of what? On the basis of simply time and space complexity. Then only you will be able to see that which one is more optimized sorting algorithm that we have, right? I hope that all these things will make much sense to everyone. Now in next video, we will start with a bubble sort, and I will try to first of all explain the concept, the approach behind that. Afterwards, I will write the implementation for the same, and then we will discuss about the time and space complexity part as well, right? So with this, happy learning to all. I hope that everyone is excited towards learning different kinds of sorting algorithms that we have. Happy learning to all. Bye-bye everyone. See you all in my next upcoming video.